Alright, Assalamualaikum warahmatullahi wabarakatuh, and hi everyone. So, welcome, welcome back to your second semester of your first year in UNIMAP. First of all, let me introduce myself first. My name is Amira binti Muhammad Nasir. You can call me Dr. Amira. Mm, so for PTT 156, which is principle to process chemistry, sorry, process chemical. So we are going to have three lecturers that are going to teach all of you. The first part will be my part lah, right, for until week 5th, and then will be continued by Dr. Miss Azrin, Nur Azrin, and finally, the course will be taught by Dr. Ang Kiani, which is our coordinator for this subject. Alright, so a little bit about me. So, I'm graduated from University Technology Malaysia in chemical engineering, and then I continue. I go into in industry working as a project engineer, which my project basically in two country, which is Malaysia and Japan. And then I work for 4 to 5 years, and then I continue to further my study in PhD in UNIMAC, alright, in bioprocess engineering. So you can contact me via the email amira@unimap.edu.my, or else you also can WhatsApp me directly lah. I assume that all of you already in the WhatsApp group, so hopefully we can use that WhatsApp group for communication lah. Alright, okay. So what is principle of chemical process, which is this is 4 credit, PTT 156. So this is our course outcome that we need to achieve by the end of this semester, right? Okay, so the first course outcome, which is short form, we call it as CO, is ability to calculate and evaluate information, either by use for material balance or energy balance, or combination of both of that. And secondly, you need to able to solve the problems, okay, involving also either or both of both of material and energy balance. And lastly, you need to learn, and you need to able to know how to simulate and solve the problems by using appropriate software. Okay, so the software that you're going to learn in this subject is called as Aspen HYSYS. So I'm going to teach one group from PTT 156 after semester break. Alright. Okay. Okay, for this subject, there is a portion for that we are going to break into. So you are going to have 2 tests, which is contribute 10% of each test. You also have, if COVID-19 subside, then if the government allow us to have face-to-face final exam, then we are going to have final exam, which is contribute you 40%. Basically, we have 5 questions in the final examination, and then you also have lab. As I mentioned just now, you need to learn about how to use a software called HYSYS, right? So that activities that using HYSYS will contribute you 30% in total, whereby 50% is contributed by your lab continuous assessment, and another 15% is contributed by your lab test. Like that, the lab test will be conducted by end of the semester lah, before you sit for your final exam. Meanwhile, for lab continuous assessment, there are 8 labs altogether, and every single time you enter the lab doing your simulation, you are going to be evaluated lah. Okay, there are rubrics that we need to follow in order to give you the marks. Alright, so anything unclear about this, you may ask me later, alright, personally or by using GC like Google Classroom. Okay, so hopefully I'm not talking too fast, and if you have any comment about my lecture, you can directly drop the comments below, or you can easily WhatsApp me to ask me to stop or to explain slowly for you to easily understand. Okay. Alright, for the first week, we are going to learn about unit and dimension. So in this first week, what you need to able to achieve is you need to able to define the physical variables, dimension, and also units. Secondly, you need to able to know how to convert quantity with equivalent dimension. And the third one is interpret result of the data from tables and graph. Okay, so we go the first part is unit and dimension. So what is unit actually? Unit is a counted and measured quantity which has value. Sorry. Let me go. Give me a second, ya. Is it easy to look at here or how? Let me go one by one first. Alright, so unit actually can be counted and measured a quantity which has value and also units. Okay, so let's say this example, 2.35 gram. So which one is value? This one is a value, and this one is your units. Okay, units can be treated like algebraic variables, which is you can edit or subtract by having the same unit. Okay, let's say this one, 3 centimeter minus 1 centimeter, which is you have same unit, which is centimeter. Then you can directly minus it and get 2 centimeter. Okay, so something goes line about 4 kg minus 2 kilogram. So since they have a same units, then you can minus it. So 4 minus 2 is 2 kilogram. Let's say I want to use 4 kilogram minus 2 cm. Those two have same units. It is for weight, right? Or mass. and this one for length. So since they don't have the same unit, so we cannot minus it. We cannot mi- minus or plus. Okay. Okay, so this one is 3 centimeter minus 1 second. So this is second and centimeter is different units. So you cannot minus it. So it's wrong lah. Okay, so it can be subtract, it can be added if you have same unit, and you also can multiply and also divide lah if you have same unit. I think most of you should be able to know this. It's simple, to uh, just to recap back what did you learn before this. All right. Okay. So if you're talking about subtract or if you're talking about multiplication or division, so these are the uh, example. Okay, 3 Newton times 4 meter. But then this is different units. But since is you are going to multiply and also divide, then it can be true lah. Okay, so this also can be done because it's division. Okay, if you look at here, this one kilometer divide by hour, so you can, the final answer should have kilometer per hour as a unit. But somehow for this example, you have 5 kilometer divide by 2 kilometer. Okay, so you can cancel out for above and below units. So what you got is dimensionless. All right, so you should know, everyone should know this. But if you don't really understand what I'm talking now, you can directly WhatsApp me. All right. Okay, so what is dimension actually? We go to dimension. All right, so unit should be settled. Okay, dimension is a properties that can be measured, such as time, mass, length, and temperature. Okay, so the dimension is T, the small capital T for time, M, capital M for mass, capital L for length, and capital T for temperature. Okay. Uh, so dimension can be calculated by multiply or divided other dimension. Okay. Okay, so this one is your dimension. The quantity and the dimension is smaller t. So these are the example of time. We using the units, which is seconds, minute, hour, right? So for mass, this is your quantity and your dimension is capital M. So what are the example of mass? You can use, what are the units of mass? Either you can use kilogram, gram, what some more? Maybe pound, all right? Okay, so this is length, quantity for length, and the unit can be meter, inch, what else? Centimeter. Okay, so you can add on as your reference. Okay, so in every value that has units, please write your units, okay, in your answer. So without, even though you have a correct value but without the units, your answers are wrong. Okay, so bear in mind when I marking your answer sheet, I'm not only looking at the value, but I also want the correct units. Okay, please bear that in mind. Thank you. All right, so we go to conversion of units. So one units can be converted to another units. Okay, the simple examples maybe a 1 meter, if you want to convert it into another unit such as a centimeter, so this one should be 100 centimeter. Another example, 1 kilogram, if you want to change the unit into gram, then this one the answer should be 1000. So this how you convert the units. Okay, this one is the simple example. So we go to the complicated ones. Okay. Okay, the units of any measured value can be expressed, can be changed, or can be converted into other units when having the same dimension. So what are the dimension just now? Where we learned just now is mass, length, what else? Temperature, and also time. Okay. So you can change the unit if you have the same dimension. So we look at the first one, kilometer per hour. So this one is your length over hour. So this is small letter T. So is it M is the same dimension as kilometer? Yes, because this yes, because this one also represent length. Okay, minute over minute, yes, it's the same dimension as is represent the time. Same goes to the other two lah, so you can convert it. Okay. Okay. The equivalence between two expressions is given by ratio known as conversion factor. So let's say you have 1 centimeter divide by 10 because you want to convert it, right? So this is your conversion factor. So what your conversion factor is where two units that have equivalent value. Okay, so these are the conversion factor. So let's say just now 1 kilogram equal to 1000 gram. So what are the conversion factor? It can be 1000 gram divided by 1 kilogram. So this is conversion factor. It can be also 1 kilogram over 1000 gram. So it based which one is upper, which one is below, it depends on what the final units you want. Okay, we are going to learn later. It should be easy. Okay, so this one is the conversion factor. Should be the common one you should know, like 1 kilogram equal to 1000 gram, and then length is 1 meter equal to 100 centimeter, 1 kilometer equal to 1000 meter. That is a normal one. All right, so volume should be you are familiar with. So some that you are not very familiar or you are not using frequently, they be on force, pressure, energy, and power. So never mind this one. You're going to learn and memorize it slowly lah. Okay, or else you just refer back to this table. Okay, conversion factor. A given quantity is converted from one unit to another new unit by using conversion factor. So which one conversion factor must be upper value and below value, right? So which one should be up, which one should be below? So this one is the rules lah. The new unit should be upper and the below should be the old unit old unit that you have. Okay. Okay, let's say this one, convert 36 milligram to gram. Okay, you need to know your conversion factor. Okay, so milligram tak ada. Okay. So what is your conversion factor? If you follow this rule, new unit is gram, old unit is milligram. Okay, so 1 gram equal to 1000 milligram. So you need to multiply the one that you want to convert. Okay, this one 36 milligram. So this one is your conversion factor. So milligram times 1 gram per 1 gram per 1000 milligram. So this one is up and this one is below. You can cancel out. So what you left the unit is only gram. So 36 divided by 1000 is 0.036 gram. So this is how you convert one unit to another unit. Okay. So another way, instead you are using multiplication here, you may write your equation by using table block like this. Okay, like this. Okay. So this one should be the previous one. I mean, the questions, the value that given to you. So let's say it is 36 milligram. And what is your conversion factor? New unit is gram and all units is milligram. So just write directly. So directly get 0.036 milligram. So by using this table, you easily can know which one you can cancel out. Alright, so this one. Left you the unit on the gram. Okay, hopefully you can follow my lecture. Okay. Alright, so next, system of units. So there are two different system of unit. First one is base unit. Base unit means units for dimension for mass, length, time, temperature, electric current, and light intensity, which you cannot this is the basic unit. Okay, let's say we are talking about force. Okay, force is F equal to ma, where you multiply the mass with the acceleration. So this one is a combination of the base unit, which is mass and acceleration. Acceleration is not base unit, okay? Mass is the acceleration, the base unit. So base unit is the simplest unit. You cannot divide or multiply to get the same unit. This is the simplest unit, okay? Multiple units is where you multiple of divide the base unit by an integer greater than 1, where you have a big number, the big number or this very small number that hard which take times to write, then you can use the multiple units lah. Okay, see kilo 10 times 3, mega 10 times 6. So this we call it as multiple unit. Okay, the third one is giraffe unit. What is this giraffe unit? Where you multiple or you divide your base unit to get giraffe unit. Okay, the simplest example here is volume. So how you calculate your volume? Where the equation should be the length, where you length times height times another one. Okay, so you get your area first, then you times with the height. So area is m square times m. So the base unit is your length, and you multiple the length 3 times, and what you get is your volume. So that is example where the derived unit you multiply or you divide the base unit to get the derived unit. Okay, next. All right, so for for the dimension, which is the length, the mass, there are few systems that our world are using it. Okay, one we call it as SI units. I think most of you has familiar with it. And the second one is American units lah. Okay, so let's say in SI unit, for the length you use meter, but for the American they use foot. Meanwhile, for the mass, SI unit basically we are using kilogram, but in American they are using pound mass. Okay, all right. Okay, that one for mass. That one is moles, where SI unit basically we are using gram mole, or we short form as mole, and then for American we are using pound mole. Okay, whereas for the temperature, SI unit sometimes using Kelvin or Celsius maybe, and then for the American unit we are using Rankine. Okay, so you should know how to convert Celsius to Kelvin. It should be simple by adding up the Celsius plus 273.15 to get your Kelvin. Rankine, the equation is not on top of my mind. I'm still looking at the conversion table. So your work, time, electric current. So what is the SI and American unit? You can find it. You can find it by using Google. Okay. So we try first by using conversion of unit. There's 3 questions here. So first one, we go to first question. If a plane travels at the speed of sound, assume that the sound's speed of sound is 1,100 feet per second. How fast is going in miles per hour? So the question want us to convert the unit from feet per second into miles per hour. So but we are doing that one first. Do the table like this first. Sorry. Okay, this one is what you have, feet per second. So what they want, miles per hour. So should be hour kat bawah lah. Alright, hour on your below. So second is here because you want to cancel out later. So 1 hour equal to 3,600 second. Next, how we are going to convert feet to miles. So you can use this table. 3.2808 feet equal to 0.0006215 miles. So feet should be at the bottom, 3.2808, and mine should be up 0.000614. Okay, so you can cancel out fit with fit and leave you mile per hour. Alright, so we try to calculate it. Okay, it should give you the same answer as given lah. Alright, so the answer is precisely the answer should be 750.04 miles per hour. Okay, so this is how you solve from one unit to another unit. Okay, next, so convert 23 pound mass feet per meter square to equivalent kilogram centimeter over second square. Okay, so 23 pound mass feet means minute square. So this one wants to have per second. Okay, so this one mean okay. So 1 minute equals to 60 seconds. So if 1 minute equal to 60 seconds. So if you have 1 minute square, so your second should be also square lah. So 60 times 60 is 3,600 square. Okay, so you settle out with this one first, then we go to the feet and centimeter. So feet should be at the bottom because you want to cancel out later, and then centimeter should be up. So what's the value? You look back at the conversion factor at this table. So 100 cm equals to 3.2808 feet. Okay, so you can cancel out here, you can cancel out here, leave you centimeter. Next, pound mass to kilogram. So pound mass should be bottom and your kilogram should be upper lah, so that you can cancel out your pound mass. So look at the mass. 1 kilogram equal to 2.20462 pound mass. So 1 kilogram here, then 2.20462. Okay, so the final answer is should be 0.088 kilogram centimeter per second square. Okay, later on you can calculate by yourself lah. Okay, so I leave it question 3A and B to you, okay, so that you can answer. Okay, in order for me to know that you watch my lecture, so your work is for this question 3. Okay, this one for your question 3. Your work is you need to you need to do the calculation, show me your calculation, and then submit to me in GC. Okay, this is your assignment lah, short assignment. Okay, so alright, so this is your short assignment. It should be simple. Show me the calculation step by step. Show me the conversion factor. Don't forget about it. Alright, okay, next. Okay. Okay, just now we're talking about base unit, right? Where the simplest unit such as mass, line, whatsoever. Okay, this one is special one. Is we talking about force. Force equal to MA, which is mass, and you multiple with acceleration. Okay. There are few naming for the forces. Okay, such as for SI unit, they are using Newton. Okay, for CGS system, they are using dyne, and for American system, they are using pound-feet. So hopefully you can remember, and these are the conversion factor. Okay, 1 Newton equal to 1 kilogram per 1 kilogram meter per second square. Okay. Okay, so this one is what we call as defined unit. Okay, Newton, dyne, pound-feet. Okay, this is what we call as a defined unit. And to a natural unit, which is we are using this the unit that we learned just now. These are the conversion factor, or we call it as GC. Okay, I think this one you need to memorize lah. Okay, 1 GC equal to 1 kilogram meter per centimeter square per Newton. Okay, so this one is the conversion factor actually. Okay, just this now we learn about force. The second one we learn about weight. Okay, weight of the object is depends on the gravitational force. Okay, these are the equation. Okay, the gravitational force GC is very based on your location. Okay, so this is the value of G, and you have noticed the value is different because of the units are different. Okay, so I just want to mention here, I just want to highlight the value of G lah. Okay, this one based on 45 latitude. Okay, if you go to moon, you should have different GC. Some goes like that lah. Okay, we go to dimensional homogeneity. Valid equation must be dimensional homogeneous. Okay, where the meaning is both sides of the equation, so let's say this are the equation, must have same dimension. Okay, let's see here. Okay, this is your left hand side, and this is your right hand side. So we look at the dimension. If you look at the left hand side, meter over second. So meter is your length, and second is your time. Okay, whereby the right hand side is here. Okay, meter per second, so it's the same as your left hand side. Meter is your length, second is your time, plus G times T. Okay, M is your length, S square is T square times S, which is also T lah. So when you can cancel each other, what you left is length over T. So the left hand side and right hand side are equivalent, or we call it as dimensional homogeneity, then this equation is valid. Okay? Okay, let's say this equation, consider the equation, this equation is valid. What is dimension? Dimension and unit for constant 3 and 4. Okay. So DFT 3TS plus 4. So the final one, your left hand side is feet. So your dimension is here is your length. Am I right? Okay. So this one is your dimension. This one is your unit. Okay. So you say unit. Okay. This is your left hand side. What about right hand side here? So 3 T is your time. Okay. Time. And unit is second plus 4. So he asking about constant 3, right? So remember you should have feet as your unit and length as your dimension. So since this one TS as a unit of second, so your 3 should have, because you want to cancel each other, right? Your unit should have second at the bottom and feet for the upper one, because later on you can cancel out with TS. Okay, so when you times 3 feet per second times second, you get feet. You can plus with 4. Okay, so 4 should be feet, because your final answer is in feet. So your dimension of feet is length and unit is feet. Hopefully you can follow me on this. Okay. All right. So this is the second assignment, short assignment that you need to do. What is the dimension for Reynolds number here? Okay. Maybe okay. So this is your assignment, short assignment that you need to submit to me together the one that you convert, the conversion unit. Okay, so next is process data representation. Okay, this is where you need to find estimate value from tabulation of data. Okay, let's say you have X, some table where when X equal to 1, Y equal to 0.3. When X equal to 2.0 and 1, Y equals 0.7. So what if the question asks you what is Y when X is 1.6? Okay. Okay. All right. So what is the value of Y when your x is 1.6. So if you look at this table, there is no 1.6, right? It's smack on the middle from 1 and 2. So that is where you can use this equation. Okay, how to use this equation? Okay, so y1 from this, okay, because x is equal, that's leave between 1 and 2, then this one become x1, 2 become x2, this one become y1, and 0.7 become y2. So y1 become 0.3 plus x, this one 1.6 minus x1 is 1.0 divided by x2 is 2.0 minus x1. Then you multiple with y2 minus y1. y2 is 0.7 minus y1 is 0.3. So you plug in and then you get the y when x equal to 1.6. Okay, you just plug it into the equation. By practicing it, you don't really need this equation anymore because you already memorize it, okay, along the way. All right, so you can practice this one. So this one is your third short assignment. Okay, please submit in PDF. Okay, please submit it in PDF in Google Classroom. Okay, so find the value of y when x is 2.2. All right, I think that's all. Okay, yeah, for the first week, that's all, which is we learn about units and dimension. Okay, for next week, we have class on Monday, asynchronous from 8 to 9 p.m. So what I'm going to do is, on that 1 hour, I'm going to give you some exercise. Okay, I'm going to give you some exercise on units and dimension. During that 1 hour, hopefully you can submit it to me. Okay, within that 1 hour. And then for this, remember the one that I asked you to do the assignment, please submit in the Google Classroom, and the deadline is on Sunday, 12 a.m. Okay, you have plenty of time to practice. All right, that's all from me. Thank you everyone for listening and watching my video. Hopefully you can understand what I'm trying to teach you. Okay, see you next week. Bye-bye.